Okay. So thanks everyone for coming. First of all, I'd like to ask how many of you are familiar with Docker in general? Okay. How many of you are using Docker in production? Okay. Very well. Thanks. So if you have some zero-day information, or if I'm not saying anything correctly, just shout out, or if you have any questions, talk about it. Like, the people that talk can get free Docker t-shirts at the end. So that's it. So first, for the rest of you that haven't heard about Docker or haven't tried Docker yet, here's a little bit about why Docker exists. So today, in this day and age, the applications that developers are making contain lots of little components, and they exist in multiple different environments while they're being made. So what happens is that you may have a piece of code that is running on a developer laptop, and then it's running on an integration testing environment, and in the end it might be running in production. And it may need different services depending on whether it's in development or whether it's in production, and all those things need little bits of configuration. And what that used to mean back in the day was doing everything manually or writing really complex scripts to handle everything. So Docker kind of takes a hint from the shipping industry, which had a similar problem where things used to, it was hard to pick how to put together pianos and barrels of wine and in which transport to put it. Like the same type of issue that occurs when you have a component of an application in a development or a production environment. So what the industry came up with was a standard shipping container which was compatible with all the shipping options, and all the people had to make sure was that their stuff would somehow fit within those containers. And that's precisely what Docker does. It makes an industry standard shipping container for us to package our applications so they can be slotted together in different environments depending on use. So a little bit about how Docker works compared to other solutions. Of course, the primary solution would be to have a physical server configured and like your own developer machine, for instance. But the industry norm before Docker came along was hypervisor-based virtualization. So that was usually a host OS would have a hypervisor here, and this thing would launch virtual machines depending on how much resources somebody would need to provision. Like an EC2 virtual machine would be something like this. And the thing is that when you run these virtual machines, there has to be an entire guest operating system in between the hypervisor and the service inside there, and that was quite wasteful, right? So the Docker runs alongside containers, and it doesn't require an entire guest operating system between the server and the application. At least not one more operating system. So here you have a little bit shown a bit better. So here is a container that has an app and its dependencies in there. So what would happen is that when you make a copy of an application and you install some new code into the container or a requirement, it would copy on write, so-called. It would just write the differences into the new image, so you can use diff-based updates. So this is a standard workflow for Docker containers. It's you have a Docker file either on your machine or in some other machine, and with that you can build a container and push it to the image registry, from where it can be pulled down to other places in your infrastructure or to other developers and stuff like that. And what would happen when you make updates to those container images is that only the diffs are shipped down to the clients who are updating updating to the latest Docker image. So let's see, let's reiterate once again the benefits of Docker. That's of course portability in the sense that it runs on any Linux kernel. I think there's some version requirement, but it runs on most Linux kernels. It's lightweight compared to physical allocation or virtual machines, and it separates the concerns. So it lets developers focus on the internals of the container, like make sure the application is configured and running in the container, and the administrators, the developer, the development operations are just taking care of provisioning new instances to run those containers. They don't necessarily need to dig inside your application to deploy your app. Right, so all the dependencies you need for your application, for this, or the part of your application which you're containerizing, like it can be a microservice app, all the dependencies are shipped within the container. And there's also obviously better utilization if you compare to a physical server where you might run only one service. You'll have some headroom left over that your service isn't utilizing. And if you use Elastic Cloud, for instance, you can have some dynamic scalability, but if you go fully, like if you can deploy just containers, your container host can be smart about where to allocate the next container to fully utilize the hardware that's available. So that's better cost performance. And if you split up your web application and services into multiple containers, then you can scale individual type of containers. So for instance, you have one container image for database, one container image for app. You can scale those individually. So let's talk a bit about the Docker engine. It's written mostly in Go, but there's some other stuff also, namely Docker Compose is Fig that is written in Python. So what it does, it uses Linux kernel namespaces to isolate the process identifiers, the network, the inter-process communication, the file system mounting, and the union file system, and it uses C groups to control resource allocations so that individual containers don't take over the entire processing power, or they don't take the entire I/O availability and stuff like that. And it's split between a daemon, which runs locally or on a server, and the client that connects to the daemon through a socket or a TCP port, and is secured with TLS encryption. What you use to work with Docker, it's containers, but containers are made from images, and images are like a read-only template that you can use to boot up a container quickly, and those can be created locally and pushed up to a central Docker registry, the Docker hub, or you can have a private registry for your organization where you share images. And out of those images, you instantiate containers, which you can just run to I don't know, deploy your app anywhere, or you can use them to interactively work, modify, and create new containers, new images out of existing containers. So the Docker Hub, if you're looking for a way to start quickly with Docker, it contains lots of official Docker images for application frameworks or for different for specific services that you are probably familiar with. Right, and a little bit about orchestration. The official part is made from 3 components, and you use Docker machine to provision locally or remotely a host to be able to run the Docker engine. Then you can use Swarm to start a Swarm manager and connect individual Docker containers to the Swarm manager from where they can be controlled. And Docker Compose can be used to easily declaratively set up multiple container application through a YAML file, for instance. Other solutions that I've been looking at are Kubernetes by Google, which actually Google has been using containers for quite a while, but they had it internally, and now with the advent of Docker, they modified their internal system, I think it was called BOLJ, to be compatible with containers, and so you can deploy declaratively to Google Google Cloud services or for instance Amazon or privately. And another popular solution is DAIS, which is a bit more complex system for basically having your own Heroku platform as a service. Right, so to start off, there's usually some things you might have to do, but if you use the installer, those will be done for you, and you will have a virtual box Docker host on your computer. So Docker runs best on Linux, and if you're developing on Windows or Linux or Mac, what you'll actually do is have Docker run inside a VM. And then, yeah. Yeah. Okay. So, yep. Okay. So what you do is you run this command which sets a few environment variables, and these specify where your Docker host is, and this one is this is actually my VirtualBox virtual machine IP and port, and where your certificates for encrypting communications reside and stuff like that. So now that I have this, I can check what containers I have running. Now I don't have any, but I can go back and see like all the stuff I had running previously, and I get wait a second. Excuse me. Yeah, so I get container IDs, which I can then use to make images out of those containers or resurrect them again. So let's just demonstrate quickly how fast it is to boot up a Docker image of, for instance, hello world. So what we do is Docker run hello world, and this I already tried this at home, so it actually used the local cache. What this did was it checked whether I have the hello world image, and before at home when I didn't have it, it connected to the Docker hub and downloaded the latest version of that image, created a container locally from that image, and launched the container, printed out the output, this hello from Docker and the instructions, and it killed it. So if I go Docker PS, there's again nothing running. But if I want to run something interactively and with a terminal attached, I can run, for instance, an image of Ubuntu very easily. I think I need to say run. So this is also cached, but what it does, it connects to the Docker hub, and it downloads an image of Ubuntu. So if it check, this is Linux running within a container. So you can run.
So this Linux is running on your virtual machine.
Yes, within Docker. Yes. So
how did you download it?
it's automatic. It connects to the Docker registry.
How fast does that work?
Yeah, just
Let's
use
Still, if you wouldn't have it cached, how fast?
Well, those are usually like 70 or 80 megabytes. So it's literally as long as it takes for you to download 80 megabytes. I'm willing to try it here, but I don't know what's the thing that I would.
It's version 12.
Another Ubuntu. Okay. Which is the dot version?
4.10. It's over stable.
Okay. So now it says it wasn't able to find it locally. And if I'm and that's it. Now it doesn't work.
How do you know it's downloading?
I don't know it's downloading, so I'm gonna check it now. I'm gonna see if there's like maybe there's a newer image instead. Okay, so I guess I don't have internet here, or do I?
VirtualBox does not have internet because there's an NAT. You have to restart VirtualBox.
Sorry to put your line demos as test.
No problem.
On this side.
I'll see if this if now it works. And so let's see any Ubuntu official tags here. So yeah, they do have 12.04 here, and that's okay. This is a 2009 laptop, so it's taking a bit to load up the machine. In the meanwhile, I can check out like some stuff I wanted to show you maybe. Right, ports and linking, cool. So very well. Now let's see if we can get this. Right. So it's 42 megabytes, and now it's downloading it from the Docker hub, and it should be running. I said to run daemonized, just so to show that. What it looks like when it's detached. So here we have a long ID for the application, and we can also see it. Which?
Especially tight.
I think I won't be able to.
Type sleep and sleep 16.
Huh? Okay. So now it's executing the command sleep 16. And we can see sleep 20, okay. That we can, for instance, connect to this container again by making it execute another command like bash, suppose, and yeah, we're inside Ubuntu 12. Well, the thing is though that after this, if you can see, these process identifiers are unique to the Docker container. You don't share process identifier space with the host. And usually when the process with the PID 1 dies, the container is done. So that's why before I couldn't see it. Another thing that Docker supports is port mapping. So for instance, if you have internal services that expose HTTP or similar ports, you can map those locally. So let's run an Nginx server, and what we'll do is we'll have it pick its own ports, and we'll see here that it is forwarding its internal port 80 to this high port over here. And what we need to do is we need to find the IP of our VirtualBox machine. And we're able to communicate with this specific instance of Nginx that is running within a container. And what you might want to do is socket those ports somehow with a proxy or something like that. Another thing that you could do is build an image that contains certain files like.
Did you just run a Docker machine with Nginx, or did you run a Docker machine and only ran the program Nginx?
So I checked Docker machine to find the IP of the VirtualBox. Yeah, this was actually running an Nginx container, so it's still running. I previously downloaded an Nginx container, which I think contains a small Linux and Nginx inside.
So there was a container which contained only Linux and Nginx?
Yeah.
Ah.
So let's see. For instance, you have a piece of static code here, which is hello world, and you want to create a container that ships with Nginx and this static code embedded inside. What you would do is make a Docker file, in which you can say, in which you can put a few statements. The from statement decides from which Docker image you would like to build your image. So you can say Ubuntu 12.04 if that's your thing to start with, or you can use one of the official images like the Nginx, and then the copy command copies the contents of the working directory into a specified location within the image. And then there's a few other commands like add, I think, for volumes, or anyways, let's try this. What you do is you choose to build an image, you give it a version, and you specify in which directory. And because I'm now in this directory, I created a new image. So if I check Docker images, I have this image which I just created here that contains that hello world code and contains Nginx. So now, if in the future I would like to run this image, I can just yeah, if I right, so I can run a Docker image, which is yep. So here we see it running on port 32771. And it contains both Nginx and the code that we gave it. Another option to use when you're developing is to run an image with some folders from the host mounted, so you can change the source code while without restarting or rebuilding the containers. What happens with mounted volumes is that they don't, even if internally, they don't transfer into the next image. So those are perfect for like working sets. But typically, when you would deploy a Docker image to production, you wouldn't like to expect the host to have your source code, because it's better to encapsulate it within an image. This is good for development. And another option is linking containers between each other, and that's done by, so let's say, I have this pasted somewhere. Right. So I've now decided to run an image of Postgres and give it an alias of database. And because it's not on this computer, it's being downloaded from Docker Hub. And I should soon have in the background a running database. And the next thing to do is to run like your app, for instance, your Ruby application or some other piece of infrastructure that connects to that image. Let's say yeah, that's okay. Cool. So now if we check under Docker, we have this Nginx running, which has a connection to the Postgres, and we can check this out if, for instance, we ask for a terminal. Right. So if we check inside the etc. hosts file, we'll see that there is an IP that is bound to the alias that we specified before, and I guess we can try and ping it, but I don't think there is a Postgres client in this Nginx image installed, but we could. Does anyone know the syntax for connecting to a host name? Okay, so this part of the demo we'll have to skip. Okay, let's see what else I have to say. Right, so there's quite a good documentation at docker.com, and the Docker Hub contains a bunch of images for you to start work with, maybe some stuff you don't even need to touch, like a Redis or a memcached image. You just put it into your stack and run along with it. But of course, there are a little bit bigger complications once you get to actually deploying this in production. And so if there's anyone that has like #1 pain point when using the Docker in production, well, does anyone have any contributions, comments?
AUFS file system is crap.
Okay.
So when you stack multiple layers, one on top of the other, when you come to like 40th layer, it crashes, so you have to repaste. So that means that you export to dark file and just import it back.
Right.
And that's one problem. And removes are really slow. Also, if you use some other file system, like there are some alternatives. They're quite slow when you're committing the image. So AUFS is crap, but it's fast. The others are slow.
But it's fast to instantiate a new image. That's the only thing that's fast at.
It works fast, but it's crap to create image from the file system because it has to copy all the files.
Okay. And what do you guys use for sharing secrets with in production with the systems?
We actually just use Docker to build code in production.
Okay, right. So there's obviously Docker is on one hand it's great for production, but it takes a little bit more orchestration to manage discoverability and sharing secrets. But it's very good for development as well, because you can quickly get developers on board by just giving them a Docker image that contains all the dependencies for the app you want to work with. So in your experience, does anyone know, do you guys use big Docker images with all the dependencies bundled inside, or do you prefer to use smaller Docker images with each service in its own image?
In my experience, it's much better if your Docker images are really small, and once you're developing, it's a good idea if you have your code mounted like through virtual mapping or whatever. But once you go over that, it goes to bundled code with your Docker image. That's one thing. And for fighting complexity or building like a proper app or whatever, I would really go into Docker Compose. It's a really useful tool. You should check it out if you're trying to build something with it. The other thing is, by default, Docker is configured so that it can use all the resources of the host. So you can, if your image or your container goes well, it can crash the host. So you have to check your settings a bit.
Do you use a custom operating system intended to running Docker containers, or Ubuntu?
No, Google Cloud and their specialized things or whatever they use.
Okay.
But yeah, you can have pretty big problems. The second big security issue with Docker is probably that most of the images that you get from the Docker repository are using root, so it's a security issue in my opinion. Makes life easier, but you shouldn't do that probably.
Right.
Do you have any experience with like hot deploys or like rebuilding images in production or something?
No, I must admit, I don't have much experience because our application has 50 users, so we didn't require Docker for deployment. Yes, but I used it for playing around, exploring.
So how does like your workflow works when you build, like you have your new version of your app, your web app? What do you do when you deploy? How does your deployment?
Right now we use the regular Ruby deployment tools without containers. Because there's only one of me. I don't need containers yet. Okay, so another thing. Meetups. I would like to invite all of you that have more experience with Docker to join me in the Docker Meetup group, and maybe we can get together and form a little bit more sophisticated curriculum for those that want to start using and deploying Docker in their organization and in production. And I think like most everyone today here can get either a Docker t-shirt or a sticker. So you're welcome to get some Docker shirts. And that's it from me for today. Thanks. Yes? Right. So right now you can use an integration testing server to, after your tests are completed successfully, build a Docker image and for shipping to production, or you can actually have the Docker hub can go into your Git repository, and after your Git repo receives a commit, it can automatically build a new image. And so if there are commands within that image, you could just constantly, for instance, fetch the latest image and run the testing command. And that image can contain the entire testing stack that you have, so you don't need to have the testing environment installed wherever you want to run tests for your app. You just need to have a container image that that pulled the latest version of the code from GitHub, and you can run that container image and get a report on whether your tests are failing or passing.
Yeah, for example, I want to test it on different Linux systems, and I failed to a production because I couldn't test it on the live system. Because it went too long, and the Docker can do like Debian, I don't know, whatever system testing. This would be really good.
Well, I didn't have this experience, but maybe we can like sit down afterwards and find a solution to that. I don't know. Sorry.
Do you have any experience with Docker logs?
I mean, I use this regular Docker logs command, so there is a Docker logs command that shows the output from the service. Yeah. So if you run a single service that outputs into the standard out, that's pretty convenient, but if you don't, then you have to make a mounted folder on your host which collects the log files.
I mean, do you have any experience with logging from
No, but I know some people, they use the regular syslog files, and some use network files. There's a good image by Fusion, good image by Fusion that has syslog properly configured. That can be used for that. Does anyone else have experience with collecting logs from Docker, running Docker images? No. Okay. Okay, Tito.
I hope you enjoyed both talks, and I hope to see you again next month. But for now, thanks for coming, and thanks again to our 3 sponsors. My computer froze. To vŽIVO for streaming, to Polygon for having us, to Total for having our rings. Just a second. Mirror. Okay, so who's gonna get the Ruby My license? Luca. Okay, come to me after it. Thank you again for coming. There are drinks in the bar. Just go there and take whatever you want, write it down, and ask people, both presenters, if you have any questions, or just mingle, you know. And yeah, see you next month. You don't want it? You can take any product of theirs. Doesn't have to be RubyMine. Yeah, me too. Marco, are you here? No. No. Robert? You don't need? Okay, does anyone want any JetBrains product? Okay, come here. Cool, it's yours. Yay! Okay, seriously, thank you again for coming. Mingle. Sam